Let's see. These guys here. Oh, again, bags full of them. It's interesting. There's three. I don't know why I have these many. All made by Cornell Dubilier. These two actually have the same type number, KMP 5P, or yeah, 4P5, KMP 4P5. Both the same value, both the same rated voltage, both made by the same company. One has a cardboard tube, and one has a plastic tube. I would lay my last nickel that the cardboard tube ones either, number one, were cheaper than the plastic ones, or made earlier and they realized, hey, you can't use cardboard because water gets through it. These are brand new. Well, see, they're new old stock. They've never been used. Like I said, I got a crap load of them. They're 0.5 microfarad, 400 volt. And you look at this guy. Made by same company, CDE, Cornell Dubilier Electronics, 400 volts, 0.5 microfarad. It's interesting, that one has a tolerance on it, plus or minus 10%. Different part number, it's smaller. These, I'm pretty sure, are paper foil. I'd have to look them up, but I'm almost certain that they're paper foil. This, I think, is a plastic, probably Mylar, judging by the number MPY and so forth. So these three capacitors all have the same microfarad value, capacitance. They also are rated at the same voltage. But look at the difference in the size. There are other things that are different about them. They're all new. I mean, they're not never been used. Been in storage as long as I've had them. Well, first we'll do this plastic sleeved fellow. 0.5 400. So put them on. Have a look at the leakage. That's rated for 400 volts. We'll take it up. 400. Okay. Huh? I'm seeing any leakage. Right? Discharge him. Yeah, and this guy, the same deal. This is the cardboard sleeved one. Maybe a little different. So it's possible that there might be some a little sogginess to that guy. It's still useful. It's not at 400 volts. It's probably work just fine. Discharge him. Put this guy on. Just a quick check. Leakage. 400 volts. But you notice it's not. There are not as many flashes on that once it gets up to voltage. So turn them down, discharge. So what about value? Start off with the newest one here, smallest one, and where's he? That wants to be, that's a what, 0.5. So we'll set this to 0.1. So up around 5 we should get a nice clear. Power factor's all the way down. Turn it up, of course that changes it. Power factor at 0, which means there's very little series resistance with it. We already established there's very little leakage across it, resistance across it, and the value is 0.53, certainly within 10%. So he's a good capacitor, very good actually. And we'll take this big guy, the one with the plastic sleeve, and he's pretty doggone close. Let's see. Yeah, these are probably, because they're not marked with a tolerance, they're probably plus minus 20%. Well, that certainly falls within that. It's a 0.54 microfarad. I'd accept that. Now here's the one, same part number, just happens to have a cardboard sleeve on it. Put him on. And let's see where he comes out. Now, two things I noticed. One, he seems a little high. And not only that, the edges of the display, I know it's a little hard to see with the focusing, they're not real well defined. Let me crank up the power factor a little bit. Yep, and sure enough, jockeying between these two, this cardboard one has a very slightly higher, actually a measurable ESR, as though there was a small resistance in series with it. Perfectly acceptable capacitor, depending on what you're going to do with it. And most things you would do with this this capacitor would work just fine, and so I keep those, depending on where it is, where I need it. Now, the ones that came out of here, these are these guys, these wax paper things, beeswax. Well, I don't know, maybe I will, depending on the time. I'll just pick one of these at random. This is a 0.01 microfarad at 400 volts. No tolerance specified. And this was out of here when I replaced. And the capacitance, well, it's supposed to be 0.01, so let's go to 0.001 so we can get up here around 10. Whoa. You barely get a indicator at all, an indication at all. Which means this thing, crank up the power factor, looky there, it widens, so you keep jockeying back and forth between these two, and you find out that is one sad capacitor. It's reading 0.015, so the value's a little high, but at the same time, look at where the power factor is. Above 20%, that's a bad capacitor. It means that there's probably, who knows, 100 ohms, 1,000 ohms. I'd have to look and find out, but the ESR, the series resistance of this thing is crap. It's too high. There are some circuits where this would just function okay, but generally where they put a capacitor, they don't want a resistor in series with it. There are places where you do, but this is not one of them. So this capacitor is shot. It's got too high of an internal resistance, along with, even though its capacitance is a little high, well, probably within spec, from what they expected of it. So its ESR is real high, and the value's a little high. Who cares about the value? That ESR bit, though, you gotta watch that. So rated at, what was this, 200 or 400? 400 volts. Let's do a leakage test. It's a paper, so yeah, that's leaky. Very, very leaky. In fact, it's getting leakier just sitting with the voltage across it. Now it's, I put it up to 500 volts. Yeah, leaking like crazy. All the full Monty. So this capacitor's got multiple troubles. It has a high ESR. It's got leakage across it. The value, it'd probably work in a lot of some applications, but it's why these beeswax guys, I almost always, as soon as I see one, I just, if I'm going to, if my goal is to get it working, I just take them out and replace them with modern plastic capacitors. I'm not even going to bother to discharge this because I know it's going to leak down itself. What's this guy? Oh, 0.1 at 600 volts. And that needed to be, because of where it was in circuit here, this actually does get 600 volts across it. And at 400 volts on the leakage test, look at that. That's a mess. That's no good. In fact, we'll take it all the way down. This is about 25 volts will trigger that. So this thing that's soggy. That's a mess. 600 volts, you kidding me? Solid glow. That's never going to charge with the current that this leakage test puts out. It's very, very low. So clearly that's shot just on that evidence alone. You don't need to bother to measure the value or the power factor of it. With that leakage condition, it's just gone. There's no point in even doing it. But I will, just for educational purposes. So I'm going to measure the value. That's supposed to be 0.1 microfarad. So we'll set this to 0.01, and it gets up around 10. Oh, really? So, alright, crank the power factor all the way up and see if we can get a... Nope. Oh, there we go. There's some indication there. Okay. So it's reading 0.155, and the power factor is 20%. Generally, with my experience with this particular meter, and actually noting what fixed something I was working on and what didn't, and taking measurements of the components I replaced and so forth, you get up to 20%, you're in trouble. They're cheap enough, just buy a new one. If it's above 5%, I start to get a little, yeah, I would never use that capacitor. That goes. Besides, I don't have to buy these things. I got thousands of them. So all these paper wax, beeswax things they're duds, and these all came out of here. I saved these because for some restorations I will gut these and insert modern components in there. I think I mentioned that before, just to keep the look up. But when you do that, please make a note and leave it in the device so that the next poor slob comes along doesn't get any surprises. Here's the electrolytic that was in here. I cut the leads off kind of close, and I have already tested this on here, but we'll go through it anyway. There's two capacitors in here. I'm only going to look at one of them because they're pretty much the same. Not much difference at all between the two. They're supposed to be 4 microfarad each at 250 volts. Well, let's do a leakage test first. Now, this being an electrolytic, we're not going to go to mica paper. We're going to go first set the voltage rate, 250 volts. Now we'll go right to electrolytic. Nothing. Where is it? Discharge? Nothing. Oh. So this capacitor it's dried out. There's not really much of it left. Increase the voltage, you get to a point where that's not acting like a capacitor at all. Very, very little. It's done. Now, granted, I'm overvolting it, but that's the only way to get any real response out of it. I'll put it to 300 volts, discharge it. Yeah. So there may be a little bit of capacitance left in it, but not much. Certainly not 4 microfarad. So what do we got here? Let's put it on scale times 1. It should bring us over to about 4 here. Nothing. Turn the power factor all the way off. Let's see. Nope. Turn it up some. Yeah, nothing. All the way up. Oh, look at that. Got something. Now that power factor is astronomical. Way past 50. And it's indicating 2 microfarad. That's classic of a capacitor, just tired, just dried out, cardboard tube, they call these dry, but nothing really could be further from the truth. All that really meant was that they didn't spill when you turned them upside down. So it's both of these capacitors in here measured pretty much the same. So that guy's shot well beyond useful. But I will save it because it's a nifty restore tool. I have my limitations. I'm not going to save every bad capacitor that ever comes out, but certain ones with particularly cool logos and stuff like that. These ones were made by Ajax, which I think is kind of nifty. Makes me think of Cleanser. So, finally, this output leakage test. Well, first we'll do a capacitance test, just for grins. This is a 40 microfarad motor start or motor run capacitor. It's rated at 370 volts AC. So DC wise, it's go well over 600 volts. It's interesting too, close tolerance. It's +6, -6%. Rated 50 or 60 hertz. It's protected and doesn't have any PCBs in it. It's a modern capacitor, a box full of them. I used to work in R&D, and there was quite a bit of stuff they'd buy and just didn't work out, so off it went. So this is 40. Let me turn this guy this way. This is 40 microfarad, and these get these leads out of my lap. And it can certainly handle 600 volts DC. But right now we'll just check the capacitance, turn the power factor all the way down. Set the range to ×10, so brings us up to about 4. Yeah, spot on. Power factor, no trouble there. Turning it to 0 widens it as wide as it'll go. And it's reading 43 microfarad, 43. Well within that spec. I don't know why a motor capacitor would have to have been so close in tolerance, but it is. And the leakage test. Now, of course, this is an oil paper capacitor, so it qualifies as mylar, or I'm sorry, mica, paper, mylar, plastic, whatever. Certainly not an electrolytic. And we'll do a leakage test on him. I'm going to set the voltage way up, all the way as high as it'll go, and I'm going to turn it on. Now that's going to glow like that because 40 microfarad, it's a pretty big capacitor. To charge up to over 600 volts, it will do it. And just to show, set this to volts, and I'll measure it once he settles down, stops winking, or maybe not winking so much. You see it slowing down. And I've played with this capacitor before here, and it will eventually stop. There may be some absorption, dielectric absorption, because of the presence of the oil in there. These days I think there's some sort of boiled out mineral oil or something they're using. But what's the voltage across this guy actually? 538. And the current input is so low, that's going to take forever. So I'm going to switch to electrolytic in mode. First I'll discharge. We'll go to electrolytic mode. Now that allows more current to flow into the capacitor to charge it up. Just because electrolytics tend to have higher values, higher microfarads. And they also tend to be a little bit more leaky, inherently leaky. So, but this isn't an electrolytic, so we'll see what happens. We'll go 600 volts plus on the electrolytic mode. We'll see it charges up much more quickly and went all the way out. And it's got 600 volts and climbing across it. So it's topping off. It's interesting, if you try to measure voltage across this in this mode without a capacitor on it, the readings make no sense, because the meter is a leakage. And with no capacitor across it, this just goes blink, 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 and every time it does, it changes the voltage value, and you get this pulsating voltage. You know, on a digital meter, you're never going to see it. Well, you'll see it, but you won't be able to take any kind of meaningful measurements. So, yeah, decreasing now because I put the meter on. So it was all the way up to 620 some volts, or 620 volts. Call it 620 volts. That's what's across this guy right now. And trust me, boy howdy, 40 microfarad with that kind of voltage across it, you do not want to cross it with your fingers. It will hurt. If not you, your fingers. I could short it out and show you the big ass spark that happens, but I don't want to wreck my stuff, so I'm not going to do that. It just makes a big pop and a spark. You've probably seen it before. So that's what this thing does. It's how it does it. I hope if you have one of these things, if not this particular model, want something similar, maybe give some insight of what this thing does, a little bit about how it does it. RC tester. I wish they'd have put on there what it is. It's an RC bridge with a leakage tester. And as an aside, if you have an old radio and the capacitors in it if it hasn't been powered up in quite some time, particularly, most especially with the electrolytics, they can sometimes be brought back if you bring them back carefully, meaning a little bit at a time. You just plug the thing into the wall and turn it on, and the tubes warm up. Next thing you know, you got a capacitor that's leaking so badly, because it's an electrolytic capacitor that's leaking so badly because over time it's become, well, deformed. And you can reform them sometimes. These aren't batteries. You can't reform a battery. Capacitors, some of them you can, at least buy some time. And this is very, very handy for that. Put the electrolytic, you connect your electrolytic to it. You set it to electrolytic, this dial here, switch. And you start off at a relatively low voltage, and you watch this. If and when it stops blinking, or the flashing gets very infrequent, you bump the voltage up a little bit more, and it'll start flashing again, or may become full glow. Give it a little while. This can't overheat the capacitor because there's so little current available coming out of this. Plenty of voltage, but very, very low current. And as you go, you approach the working voltage of the electrolytic capacitor. Let's say it's a 450 volt one, and so you get up to where you've got this dial at 450 volts, and this is flashing, every once in a while. Just let it sit like that for a while. If the capacitor shorts out, it won't hurt this. It'll just make the light glow steady. It may render the capacitor finished forever because of an internal short, but you know, it's worth the risk. If a capacitor's that bad where it's going to fail at its working rated voltage, working voltage anyway, that get rid of it. You don't need it in your radio or whatever it is you're trying to repair or build. It not only has the capacity, no pun intended, to measure the capacitance, check the ESR, its series resistance, check its leakage across it, and also, in the case of electrolytics, actually restore the thing. These come in quite handy for that, particularly this model. The ones I've seen, I mean, this thing, it's got more than really necessary. I've seen these things that had one tube in them, and its only purpose was a rectifier. I've looked at the schematics, and it's okay. I can see how they're doing it. But it's junk. Particularly the Zycos, man. Don't even bother with them. If I run across another one of these, I will snatch it up. As I said, there are better ones. The military ones, some of those I've seen are top notch. They work the same way. They've got a couple of other bells and whistles on them, but you know, they're more precision dials and things like that. And you can measure smaller capacitances. This thing claims it can go down to, I think, like 100 picofarad or something, but of course you can't do that with test leads. This used to come, it came with 2 naked probes that just plugged in there, and there was some way to attach the capacitor directly to it so that all this lead length, which adds capacitance, didn't interfere with your measuring. I don't use this really so much to measure the 100 picofarad capacitors or anything lower than that. I have other methods to do that. This is for the, you know, 0.00 something to 200 microfarad paper and you know, mica paper and electrolytics. I'm calling this repaired. Other than I said, I'm going to put a line fuse, safety fuse in it, just to be safe. If I forget and leave it on, it doesn't smoke, and if something goes wrong, and it won't burn out the transformer in 5 minutes. So that's the deal. Still got to clean up some stuff, just those smudges and fingerprints and things. Clean this off. Clean the outer box, and put her back together, and it goes back on the bench. Only this time I'm going to put a cover over it so it doesn't get so daggone dusty. But I will be using this quite a bit in the near future. I've got a bunch of radios that needs attention. The old lady liked to kill me, so to that end, she's almost ready to go. See ya.